All right, welcome to the Unit 7 test review with radicals. So let's get started. We have the -7 squared of 294. We're going to look at about perfect squares. And 294, let me make this bigger, is the perfect square that will divide out of that is 49 and 6. The square root of 49 is 7, so we'll multiply by 7. And that always, the -7 is on the outside. It's just waiting to be multiplied by something that comes out. And then the 6, there is no perfect square for that. That can divide out of it, so that stays there. And that's -7 times 7 is -49. So simplifies to -49 square root of 6. Number 2, I'm just concentrated on what's underneath the radical. That's all I look at. And it is a cube root, so now we got to think perfect cubes. So I'm just going to write the -3x squared on the outside, and then we're thinking about perfect cubes. So a -128 is a -64 and 2. And then x squared, the x squared cannot come out, but the y cubed will, because that's a group of 3. If the negative messes you up, if it's a cube root, if it's a negative underneath, that will always just come out. It'll come out in front. You can multiply by -1, and that'll always work. So on the outside, we have the -3x squared already, and then we have the cube root of -64 is -4, so we get times -4. Cube root of 2 is nothing, and then we have the cube root, well, it's not nothing, but it's not something we can, there's no perfect cube with it. Cube root of x squared, there's not enough x's, there's 2. The y can come out, so it's just a y. We have one group that comes out, so y, if you have it to the first, not a big deal. Technically shouldn't have it because it's simplified. All right, now we put this together. We have -3 times -4 is +12, x squared, y, and then a cube root of 2x squared. There we go. All right, number 3. So it's a fourth root, so now we got to think perfect fourths. So 2 to the 4th, I don't have these memorized, so I'm just going to write them down quick. 3 to the 4th is 81. 4 to the 4th is 256. And so now I think, what's the biggest number I can divide out of 512? Well, that's 256. You can keep going. You could do 5 to the 4th, but it's bigger than 512, so I'm not worried about that. So it's 256. So I'm going to write 3x to the 5th, fourth root. 256 is the perfect fourth, and that's times 2. And then I'm going to split it up. This is not something you have to do. 12 divides by 4 evenly, and then there'll be an x left over. And the y, 60 divided by 3 divide by 4 divides evenly. Perfect. So I don't have to split that up at all. So we have 3x to the 5th times the fourth root of 256 is 4. The fourth root of x to the 12 divided by 4 is 3, so that'll be x to the 3rd. And y, 60 divided by 4 is 15. Sorry, 15. And then a fourth root of 2x. So we have 3 times 4 is 12. X times x to the 5th times x to the 3rd. We add those exponents. Y to the 15th, fourth root of 2x. And that is our final answer there. All right, moving on. These other ones go a little bit faster. Write the exponential form. So the 2 is our numerator. So the exponent, when it starts out with the exponent, is your numerator. So, and what's underneath the radical, I always put in parentheses. Keep it in parentheses when we convert. So it's 2 is your numerator, and then the 3 is your denominator. So it's 2/3, and that's exponential form. That's all we got. All right, the 6 and the next one, that is all by itself. It has nothing to do with the radical. It is in front of it, so we've got to keep it in front of it. Now when it comes to the actual radical itself, this part here, that's going to convert. We have 3, keep whatever's underneath the radical, keep it in parentheses, and that's raised to the 5. That's your exponent, your numerator of the exponent, and your denominator is 2. It's a square root. And that is it. Now the biggest thing I would say is make sure that that 5 halves and the 2/3 in number 4 is up higher and smaller, so then it looks like an actual exponent. All right, number 6, we actually got to go from radical form, or write it in radical form. Right now it's in exponential form. So I'm going to do the denominator is your radical, so it's a cube root, and what's in parentheses, I'm going to keep it in parentheses, and then it's raised to the 4th power. What I found in class was easiest for you guys seemed to be to distribute the 4 first. So this is going to be a cube root of 6 to the 4th, and now we have an exponent raised to an exponent, that's going to be multiply, so 32. Now I'm going to look at each individual part and simplify it. We have 6 to the 4th, so I think I have 4 of 6s, that's what I would think of, and I can do one group of 4. So in other words, you can write it out like this. There's the one group, so that 6 is going to come out in front, because the cube root of 6 times 6 times 6 is just 6. And then the x to the 32, 32 divides by 3, goes in 10 times, so that's x to the 10th. And what's left is 1 6, and 10 times 3 is 30, and those 32 x's, so that means there's got to be 2 left over. And there's your final answer. All right, so that's first page. Second page, we got some multiplication, adding, and division. So this is B. So first thing, if you have 2 monomials multiplied together, we're just going to multiply, put them together as 1. So negative 3 times 12 is negative 36. X to the 4th times x squared. Add those exponents is x to the 6th. Y to the 1st times y to the 2nd is y to the 3rd. And let's look to simplify. So perfect cubes, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64. 36 doesn't divide by any of those, but I do see a negative inside, and that's really like negative 1 to the 3rd. So you cube root negative 1, it's going to be each negative 1. So that negative will come out in front. You can put the negative 1 there if you'd like. Cube root of x to the 6th is 6 divided by 3 is 2, so x squared comes out, nothing left over. 3 divided by 3 is 1. And what's left over is just a 36. And then I'm just going to clean this up a little bit. Negative 1 times x squared, we're just going to write it as negative x squared. And y to the 1st, we just write y. So there is your answer for number 7. Number 8, we have addition. 2 operations here actually together. We have addition and we have multiplication. Got to do multiplication first. So negative 7 square root of 2 plus 3 square root of 8. So square root of 8 times 3, square root of 8 times 2. And after you multiply, you always simplify. So each individual term. So I just do a quick check. Square root of 2, can I simplify? No. Square root of 8, yes, I can. So that middle term is going to become 3, and then 8 divides by 4, and 2. And then square root of 4 is 2, and we're just going to come out with a 3. 3 times 2 is 6, and there's a 2 left over. Square root of 16, look at the last term, is square root of 16 is just 4, so minus 4. And I'm just going to write that first term all the way down to the bottom. And now I got to add like terms if I have any. Well, I do. There's a square root of 2 here and a square root of 2 here. So all you got to do is take negative 7 and you're adding 6. That's a negative 1 square root of 2. And the last thing I'm going to do is I'm actually going to move this. Typically we don't have terms after radicals if we can help it. So I'm going to move this negative 4 up front. So it's going to become a negative 4, and then a negative, that 1 doesn't have to be there, so this becomes minus square root of 2. If you write it after, I'm fine with it. It's not that big of a deal. All right, number 9, cube root of 9. So I need to think about perfect cubes. So I'm just going to write them down again. No harm in this, doing this every single time. And I can stop here because I got to think about what number can I. So I guess the easiest thing to do, what some of the students do, is like they look at the number underneath. The cube root is 9. And some of my students just take the perfect cubes and divide. 8 divided by 9, is that a whole number? No. 27 divided by 9, is that a whole number? Yes. So that means we need to multiply by 3. So if you multiply by the cube root of 3, that'll get you cube root of 27, which is a perfect cube. and then I'm going to make sure that 5 comes along. That's on the outside. And then we got to multiply the numerator also by the cube root of 3. So multiplying straight across, we got the 2 that's on the outside, and then 5 times 3 underneath the radical is 15. And 15, I'm going to, after you multiply, it's always simplify. Can we simplify? Cube root of 15, no, there's no perfect cube that can divide out of it. So the numerator stays the same. The denominator, the cube root of 27 is 3 times 5 is 15. Now the only thing you can do at this point is, after you simplify, is can you simplify the factors, the coefficients on the outside, so 2/15, that fraction, and you cannot. So that's your final answer. 10. All right, here we got square roots, so you're thinking perfect squares. So 2 squared, 3 squared, 4 squared. You guys are a little more accustomed to these. And I'm not going to write them all down because you guys, I think, know them by now, like what they equal. But you got to think, what can I multiply that square root of 10 by to get one of these perfect squares? So like 4, 9, 16, 25, all that. And it really would, it goes down to, it's the only one you can do is 100. So you got to multiply by, and it just happens, and it always works, if you multiply by the radical itself, when it comes to square roots, that'll always give you a perfect square, because like 10 times 10 is 100. So you got to multiply the numerator by square root of 10, which is 80. 8 times 10 is 80. And then multiply the denominator. So square root of 10 times 10 is 100. And now after multiplying, you have to simplify. So square root of 80 in the numerator, what can you divide that by? By 4, 16. 16 is the biggest. So 16 and 5. And if you, and then the denominator is the square root of 100. This term, that middle, that what I just wrote, you don't have to write that. You could go straight probably from the square root of 80 to this step right here. So square root of 16 is 4, and the 5 comes along, so square root of 5, and then 4 times 10 is 40. And then we should be able to simplify this in the end. The 40 and the 4 divided by 40. Divide the numerator by 4, divide the denominator by 4. And so our final answer is 1 times the square root of 5 is the square root of 5. You don't need to write the 1 there, and that's over 10. That's your final answer. And don't do the 5 into 10, because that's not a 5, that's a square root of 5, which is like a 2.1 something. It's not an actual 5 there. All right, moving on, number 11. The denominator I see is square root of 3, so I need to multiply by the square root of 3. That'll get you that square root of 9. In the numerator, there's 2 terms, so I need to distribute. So square root of 3 times the square root of 6 is the square root of 18, minus square root of 2 times the square root of 3 is the square root of 6. Multiply the 2 here, 4 square root of 9. And then after you multiply, we have to simplify each term. So square root of 18 can break down into 9 and 2. 6 cannot simplify. And 4 times square root of 9 is 3, so that's 3 times 4 is 12. We have square root of 9 is 3. The square root of 6 I cannot do. And that's over 12. To simplify this, you'd have to look at the 3 if there was a number out here, and the 12. All of them have to equal something, like to divide by something in common. A common number that you can divide them all by, but they don't. So that's your final answer. All right, number 12. So this one's similar to the last one, but we got to figure out what to multiply by. It's a perfect cube, so what can we multiply perfect cube by? So 2 times what? And that's going to be, I need the easy one is 8, so I multiply by 4. 2 times 4 is 8. So that's going to become cube root of 8. Cool. So that means we have to multiply the numerator by the same thing. But I see a binomial here because of this plus, it's 2 terms. So distribute. So 2 fourth root, or cube root of 4, plus cube root 6 times 4 is 24. So after you multiply, you then got to try to simplify. So I look at the first term, nothing to simplify. The cube root of 4 I cannot do. Look at the second term, cube root of 24, that is divisible by 8. 8 and 3. So I'm going to have 2 cube root of 4 plus cube root of 8 and 3 over cube root of 8 is 2. Well, that's a 3 there. Okay, and then I'm going to write this down below. I have 2 cube root of 4 plus cube root of 8 is 2. We don't have a perfect cube for 3, so that stays there. And 5 times 2 is 10. The last thing you're going to do is look at the 2, and the 10, and see, can we simplify that? I'm just checking my notes quick. And so 2 divides by 2 is 1, 2 divides by 2 is 1, 10 divides by 2 is 5. If you took notes or from earlier, like if you took my, from second block, I forgot that 5 on my answer key. That's why I was hesitating. Wouldn't be Mr. Johnson's work without some little error because I was working too fast. So this is your final answer. All right, moving on to C. C is, we got divide by -5, so you have to isolate the radical. So your goal is to get this radical all by itself. And that -5 is attached by multiplication, so we got to divide. Once you get the radical, in this case it's a square root by itself, then you can undo it by, this in case you square it. Square root and square get canceled. You get 4a plus 13 equals 7 squared is 49. You subtract 13 and you divide by 4. And since we did not have any kind of a squareds in here at all, no quadratics, this is our final answer. We don't have to check it for extraneous solutions. Number 14, the radical is already isolated. There's no terms on the outside of it. There's no like multiplication or addition here or here. So that means it's isolated. So now we just undo the radical by squaring and square. And then I see an x squared, so there's my quadratic. So now I need to move all the terms to one side. So x squared plus x equals 30, minus 30, minus 30. X squared plus x minus 30 equals 0. If you want to go to Desmos, you can, or the calculator, you can see on the calculator how to find where it crosses the x-axis. So I'm just going to pull up Desmos because it's a lot faster for me. So x squared plus x minus 30, and it's going to cross at -6 and 5. So -6 and 5 are our two solutions. I'm just going to put that down below because without the calculator it's pretty easy to do this by factoring by hand. It's actually faster. So when A is 1, you can do what two numbers multiply to C that add to B. So what two numbers multiply to -30 that add up to 1, and that is -6 and 5. Nope, +6 and -5. So our factors are x plus 6 and x minus 5. And then you can set each factor equal to 0 to get your solutions. So that's how you do it by factoring. Pretty easy. Subtract 6, you get, well, there you go. So you subtract 6, you get x equals -6. Here when you add 5, you get x equals 5. Okay, because we got an x squared, a quadratic, we do have to check these answers. It's part of the problem. And you always do a check with the original problem. So no, don't do any math, just straight check from the original problem. So -6, substituting in the left side, I get -6 equals 30 minus, I'm going to put it in parentheses because I don't like minus and negative, I love parentheses. Minus a negative is a plus, so that's 30 plus 6 is 36, and square root of 36 is 6. Unfortunately, -6 does not equal 6. That means -6 is not a real solution. We call it extraneous. Okay, next one, I'm going to check x equals 5. So put Put it back into the original equation. (30 minus 5 is 25, square root of 25 is 5. All right, that one's good. So that means 5 is the solution. That's the only one. Negative 6 is not. That's called an extraneous solution. You don't need to write it down. It just means that it's not a real solution, even though that you mathematically got it. All right, number 15. So this is cube root. When you're talking with square roots and cube roots, it's all about look at your radicals right away. Are there either one of the radicals, so in this case there's two radicals, either one of these radicals, are they isolated? Meaning, are there either one of them not have an operation on the outside? So the first one on the left has a times 2, but the one on the right side of the equal sign is already isolated. So if it's isolated, all you gotta do is raise it to the third power. Okay, on the left side, because we have this 2 here, that also is gonna be raised to the third power. And then when you have cube and cube root, those will cancel. So that's gonna be times 4x. And on the right side, cube root and cube cancel. So it's really nice. So 2 to the third is 8. And 8 times 4 is 32. And now we just got to get these like terms together. I'm going to put my x's on one side, so minus 2x. And simplify that. Divide numerator by 5, denominator by 5. And you get 1/6. Didn't do anything with the quadratic, so you don't have to worry about checking your solutions. And number 16, isolating the radical. The radical's right here. I have 2 operations on the outside. Hopefully you see a multiplication here and addition. The number that's being multiplied is the 3, and the number that's being added is the 10. So the number that's being added is what we need to do first. Remember, it's the reverse order of operations, GEMDAS, with these. No. I need to learn how to. So you have addition, we're adding 10, we got to subtract 10 first. That's a positive 3, so I'm going to keep it a positive 3. And then divide by 3. You get the square root is now isolated. Awesome. And that's negative 2. And we can square this and square the right side. And square root and square cancel out. And you get 4. And then add 9. You get 13. Because we didn't have a quadratic, you don't have to worry about checking it. You can always check every single one if you want. Hopefully this helped you. You're more than welcome to email me with some questions. Thanks.